So welcome everyone to this 0 PM webinar. Thank you very much for joining us today. Today we are having a webinar that's called The Implementation of the Essential Use Concept from a Chemical and Psychological Standpoint. And we're bringing you the webinar from the project 0 PM, which is a research project funded by the European Commission. And we're looking at preventing, prioritising and removing these PM, persistent and mobile substances, from the environment. So for those of you who don't know me, I'm Sarah Hale. I'm the host of the webinar today, but actually we're hearing from 3 speakers. We have 3 separate accounts of what we're talking about. So first of all, we're going to be hearing from Roman Figuer, and he works at Stockholm University. Roman has a master's degree in environmental sciences, very soon to have a PhD as well, specialising in risk assessment and management of hazardous chemicals. So he's going to be talking to us about essential use from the chemical standpoint. Then we have our second speaker, who is Rahul Agarwal, and he works at Chalmers University. He has a bachelor's degree in civil engineering and also a master's in environmental engineering. And his work within the project, and also today, he's focusing on life cycle assessments and characterization factors. So that's what you will hear about from Rahul. Then we will hear from Ellise Suffill. She works at the University of Vienna, and she works in the environmental psychology lab. So we have a totally different perspective here. She's looking at how people both affect and are affected by their environment. So here we're looking at the public perception of risk. So what I will say to you is, when you have a question, please pop it in the Q&A box, and we'll try and go through as many questions as possible at the end. Hans-Peter will be doing the questions. If we don't get time to answer a question, please leave your contact, your email or something, and we'll get back to you afterwards.
My name is Roman Figuer. I'm a PhD student at Stockholm University, and today I'm going to talk about how to implement the essential use concept from a chemical standpoint and from the technical function of a chemical standpoint. But before I start, I think it's good to, so that we are all on the same page, to remind what the essential use concept is. So it was first introduced in the Montreal Protocol back in 1987 to control the ozone layer depleting substances. And in this decision, the parties, they agreed that a controlled substance should qualify as essential only if it is necessary for the health, safety, or if it is critical for the functioning of society, and that there are no available technically and economically feasible alternatives that are acceptable from the standpoint of the environment and human health. Since then, the European Commission, in their chemical strategy for sustainability, suggested that the essential use concept could be implemented in chemical legislation in the EU to regulate the most harmful chemicals. So that was back in October 2020. And since then, the European Commission published a guiding principle, a potential essential use concept framework last year, where they specify what type of questions one should answer to determine whether a use is essential or not. So I'm just going to give you a quick overview of it now. So the first step is to, I call it scope the assessment, meaning to define the use of the chemical of concern. Where is it used? Which type of product, which type of process? Then to define the functions that the substance is providing to the product or to the process. And once we know this, one can start to evaluate the essentiality of the use of a chemical of concern. And that brings back to answering 3 questions. The first one is whether the technical function delivered by the substance is needed for the final product to deliver its service, or for the technical performance of the final product. The second question is whether or not the use of the substance of concern fulfill at least one criteria to be considered as necessary for the health and safety, or to be considered as critical for the functioning of society. And the third question is whether or not there are no safer functional alternatives available that are capable of providing similar functions. And only in the case where the answer to those three questions is no, sorry, is yes. Sorry, my bad. Only if the answer to those questions is yes, then the use could be considered essential. So in my presentation, I'm going to talk about two main groups of chemicals that are considered as the most harmful chemicals. The first one is PFAS, or per and polyfluoroalkyl substances. In this presentation, I'm considering that all PFAS can be considered as most harmful chemicals. I'm not going to question this. It's just a hypothesis I'm making. And I define PFAS as any substance that contain a CF3 or a CF2 in the group in the molecular structure, as suggested by the OECD back in 2021. The second group of chemicals I'm going to focus on is the PMT substances, because we're 0 PM after all. For this presentation, I will consider a substance is a PMT if it is persistent and toxic according to REACH, and if it has a log of KOC lower than 4, as it was suggested by the German Environmental Agency when they first looked at PMT substances in REACH registered substances back in 2019. All right, so if we go to the first step, like scoping the assessment, or to define the use and define the functions of the chemical of concern. So with the PMT, what we did is that we looked at PMT substances used in cosmetic products. So we took the PMT and VPVM list of substances registered under REACH, published by the German Environmental Agency in 2019. And we looked at which of those substances were used in cosmetic products that are available on the European market. To do that, we used two databases provided by Chemie Lupin and Cosmetics, where they looked at ingredients actually in use in cosmetic products on the market. And what you see here on this figure is that the number of ingredients used in cosmetic products that are also PMT. So you see that it is around 6% of the total ingredients used in cosmetic products, and that PMT substances are actually used in any type of cosmetic products. So then based on this, we looked at occurrences of each and every one single PMT substances, and based on the occurrence, we selected 3 case studies for further evaluation. The first one was climazole, which is used in shampoos as anti-dandruff agents. Second one was benzophenone 4, which is a UV filter that is used in any type of cosmetic products. And the last one was allura red, which is a pigment that is also used in any type of cosmetic products. So then once we knew that, we determined the functions provided by those substances. And to do so, we followed the functional substitution approach, which basically encourage any assessor to determine 3 different levels of function provided by a chemical. The first level is the most common one, is the chemical function, which is basically the technical function of a chemical. It's determined by its physicochemical properties, which themselves are determined by its molecular structure. Then once we know the chemical function, we can try to determine the end-use function, which is the specific purpose delivered by a substance in the specific product. In other words, what is the product getting from having the chemical function in it? What does it bring to the product? And the last level is the function as a service. That is basically what us, consumer, us, society, do we get from having this specific chemical function in this specific product or process. So we try to determine these 3 levels of functions for our PMT substances in cosmetic products. I'm not going to detail everything here, but everything is available in the paper that is published. I'm just going to take the example of allura red now. So like I said, allura red is a pigment that is used in, among others, lipsticks, makeup. That's used to provide a color to the formulation of the cosmetic products. And in case of lipstick and makeup, is to provide color to skin, lips, nails, hair, you name it. It's also used in soap. And based on an interview we had with industry representatives, they're using red pigment in soaps only for marketing purposes because, according to them, consumers prefer to buy a soap that looks red if it smells like strawberries. Apparently, a soap that smells like strawberry, raspberry, we like it when it's red. Imagine yourself, you have a soap smelling like strawberries and it's blue, might be a bit weird. So that's the only reason why they're using pigment in soap. We try to take a similar approach for PFAS, and that's how we built the 0PM alternative database. We try to map out all PFAS uses of PFAS, and for each use, we try to determine the chemical function provided by PFAS, its end-use function, and function of the service. Again, I'm not going to detail everything now. I'm just going to take one example for fluorinated gases. So these are all the sub-uses of fluorinated gases we have identified. And if you look at only one of them, like the fluorinated gases used as foam blowing agents, in that specific case, fluorinated gases, the chemical function is a foamant. The end-use function would be ensuring the extension of a foam. And those foam blowing agents, they're used among others, in insulation foams. And in that case, the service derivative would be the insulation of a building. So once we know this, we can answer the question quite easily whether or not the technical function is necessary for the technical performance of the end product. Like if we take the example of Arial Red again, in the case of a lipstick or makeup, just imagine you have a red lipstick, you take the pigment out of the red lipstick. In other words, you take the color red out of the red lipstick, and suddenly your lipstick wouldn't have any color anymore. So it will lose its all purpose. So in that particular case, you could say that the red pigment is necessary in the red lipstick for its technical performance. But in the case of the soap, if the pigment does not do anything to clean your cells, like in the cleaning property of the soap, it's just there for marketing purposes, then it's not necessary for the technical performance of the soap itself. You could have the same soap with or without the pigment. It will work just as well. So in that specific case, we could say that Aloe Red is not necessary for the soap. So it's not essential. We could already conclude that it's not essential. We could take the pigment out of the formulation and stop the essentiality assessment right there. No need to try to find alternative, no need to determine whether or not it's necessary for health and safety. Just because it's not necessary for the soap to provide its technical performance, we can just say it's not essential, full stop. But for the ones that are in the first category, so for the ones that are necessary for the technical performance of the end products, one might want to determine whether or not there are alternatives available. And that's where these three different levels of functions is important, because it allows to identify any type of potential alternative and not only alternative substances. If we go back to the example I gave on the PFAS used as foam blowing agents, if you focus only on the chemical function, you might identify potential like other blowing agents that are non-fluorinated as potential alternative. So you could, for instance, identify pentane, cyclopentane, and methyl formate as potential alternative to PFAS. But if you look at from the service function perspective, then here you can consider that other insulation materials are also potential alternative to PFAS used as foam blowing agents. And then suddenly fiberglass, rock wool, cellulose, hemp concrete, all those other insulation materials could be considered as potential alternative. And that's in the essentiality assessment, is important to have those both level of evaluation when you look for alternatives and not consider only chemical alternatives. And that's the approach we try to do in the 0PM alternative database, where we try to identify any type of alternative to PFAS across all the uses categories. And that's a novel picture. By following this approach, we could identify 530 different potential alternatives for the 325 uses that we have listed there. We haven't found any alternative for 83 of those uses. And here you have an overview of the type of alternatives that are listed in the database. If you want more information, the database is freely available on the 0PM website. And this is the paper that is now published detailing the work we've done regarding this database. But to sum up, if there's one thing I would like you to remember based on my talk, is that when we talk about the essential use of substances of concern, the question is not, is the chemical essential? The question is neither is the product or process essential. The good question to ask is the function provided by the chemical of concern in a specific product or process essential for society? And to properly do that, it's critical to understand what are the different functions provided by the chemical of concern. I didn't touch upon that, but the proper alternative assessment is still needed if we want to prevent regrettable substitution. And social sciences are also needed to properly evaluate whether the function provided by a substance in a specific product is necessary for society or essential for society. And with that, thank you. I now leave the floor to Raoul, who's going to talk more about alternative assessment.
Thank you, Romain. So today I'm going to talk about our work at Chalmers, what we are doing at Chalmers regarding chemical and their characterization factors. So first I will give a context of characterization factor, why we need characterization factor. So at Chalmers, we are working with the life cycle assessment of the product system. A product system can be anything. It may be like your rain jacket, it may be your laptop, it may be your phone, or any other product. In the life cycle assessment of a product system, you can quantify different impact. You can quantify climate change impact, eutrophication, ozone depletion, along with toxicity impact. That is a little bit broader than when we are talking about chemical risk assessment. In the chemical risk assessment, we are focusing on one chemical at a time. But in the life cycle assessment, we can quantify the chemical emission from the product system and combine all the chemical emission into one total toxicity impact. So to do a life cycle assessment of a product system, there are 4 stages. The first one is the goal and scope definition. In the goal and scope definition, you have to define your system, what you are including, what you are not including in your product system. Then the second part is the life cycle inventory, in which you quantify all the input and all the emission. For example, if you have a product like rain jacket, you are using some chemical coating. So chemical is input to the rain jacket. There may be a lot of other chemical used in the processing. So in the life cycle inventory, you quantify all the input and all the emission. Input may also include chemical input and along with chemical emissions. And then the part 3, life cycle impact assessment. In the life cycle impact assessment, you convert your life cycle inventory into the impact. But to convert your life cycle inventory into the impact, you need characterization factor to convert the emission into the impact. And the fourth one is interpretation, in which you analyze your result, what they mean, whether they are high or low. You can compare the results. You can find uncertainty in the results. So if we come back to the stage 3, life cycle impact assessment. In the life cycle impact assessment, you can quantify different types of impact. For example, you can find the total carbon footprint of your product. You can also find total water use, total energy use, or total eutrophication impact. But at Chalmers, we are focusing on ecotoxicity impact. So if you have a product and you are using a lot of chemical in the product system, to calculate final ecotoxicity impact of the product, you have to quantify the emission of the product and then convert the chemical emission into the impact. And for that conversion, you need characterization factor. That is why we are calculating characterization factor, because if you have a chemical in your inventory but you don't have the characterization factor, then you cannot calculate the impact. And if you are not including the impact of that chemical, then you are underestimating your total toxicity impact. For most of the persistent and mobile chemical, we don't have the characterization factor. That is why we are calculating the characterization factor. That is the context. The next part is how you can calculate the characterization factors. To calculate the characterization factor of a chemical, you need to model the environmental fate exposure and effect of the chemical. For example, if you have 1 kg of chemical A released into the air compartment, it will not remain in the air compartment. It may go to the water compartment, it may go to the soil compartment based on the chemical properties and the environmental condition. So you need to quantify the final value of the chemical in different compartment, and within that compartment the chemical will lead to exposure to the species, and with that exposure it will lead to effect. So you have to model the environmental fate, exposure and effect of the chemical emission to calculate its characterization factors. At Chalmers we are using the tool called UStock to model that environmental fate, effect and exposure to calculate the characterization factors of chemicals. So a little bit regarding the effect modeling within UStocks. In UStocks, effect factors are basically the representation of the effect of the chemical on the ecosystem. But first we have to understand in the ecosystem there are different species. There are multiple species, millions of species, and how you quantify the effect of the chemical on the ecosystem. To quantify that, you need to calculate the effect of the chemical on different species, and then you model the different species to find the total impact of the chemical on the ecosystem. In UStocks, you quantify the impact of the chemical on different species by calculating EC10 value for each species. It is the concentration at which 10% of the species will be affected, and then you model all the species in species sensitivity distribution curve to find the effect factor. That is calculated in simple terms the concentration of the chemical at which 20% of the potentially affected fraction of the species will be affected. But so how we are calculating characterization factor in our study? So in our study we have 64% mobile chemical that include PFAS, triazines and triazoles. But we realize once you release the chemical in the environment, the chemical may not remain the primary chemical. It may transform into different transformation products. So we also included the transformation products of the persistent and mobile chemical that are more persistent and more toxic than the primary chemical. So after that we have primary chemical and we have transformation product. Then we have total chemicals, and then we calculated the ecotoxicity data from different databases like REACH database along with Comtox database, and then we harmonize the data. Why we need to harmonize the data? Because normally the data is not compatible with the format we need to calculate characterization factor. That is why you need to harmonize the data, and after harmonization you can use the harmonized data to calculate the effect factor, and after effect factor you can calculate the characterization factors. A little bit about harmonization. The main purpose of harmonization is to make the data compatible with the calculation of the UStock characterization factor. Because normally the data we are using is not generated to calculate the characterization factor. It may be generated for other purposes. For example, we are using a lot of data from risk assessment or a lot of regulatory data. So it may not have the same format. For example, in UStock we need EC10 chronic values, but the data may have different endpoint. It may be EC50, or it may be acute values, or it may not be for freshwater ecosystem. It may have different ecosystem. That is why we need to harmonize the data. So in our study, we propose a 19-step harmonization process in which whatever data you have, you can harmonize to make it compatible with the UStock methodology to calculate the characterization factors. So what we have calculated in our study. The first part of the result is the characterization factor. In our study, we calculated characterization factor for 67 chemicals that include 64 primary chemicals and 3 transformation products. Out of these, 47 were calculated based on experimental data, 17 were calculated based on estimated data, and 3 were calculated based on group average. But when we are going from experimental to estimated to group average, we are reducing the reliability of the data we are using to calculate the transformation products, to calculate the characterization factor of the chemical. But there is a lack of experimental data. That is why you have to fill that data gap, you have to use some other ways like estimated data or group average. On the right side, you can see the figure. At the bottom of the figure, we have all the chemical and their characterization factor on the y-axis. One thing you can notice that in the calculation, we have 3 groups. We have PFAS, triazines, and triazoles. But when we calculate characterization factor, the values of their characterization factor is in a range. It is not simple to say if we know the grouping of the chemical, they have very high characterization factor or very low characterization factor. So within a group, the characterization factor values can vary. If you want to read more, you can go to our published paper and you can have all the results regarding the characterization factor we calculated for persistent and mobile chemicals. The second part of result is extrapolation factor. As I told you before, in the harmonization process, sometimes you need to harmonize the data. For example, if you have different endpoint, in Hughes-Stock, you need EC10 value to calculate the characterization factor. But if you have different endpoint, if you have EC50 values, or if you have acute values, then you need to convert your endpoint to the EC10 chronic values. Normally, either you can do it with the help of generic values, or you can do with the help of extrapolation factor based on different species. In our study, we calculated extrapolation factor for different species group because there were lack of availability of extrapolation factor, and if you are using extrapolation factor for different species rather using generic extrapolation factor, then you can calculate the endpoint more accurately. In the figure, you can see different species and the comparison of the extrapolation factor, which are generic factors, and sometimes they differ a lot. The other part of the result is we calculated the extrapolation factor based on the data set of more than 300,000 data points that are harmonized. That is a little bit much bigger than the previous calculation of extrapolation factor that was based on around 10,000 to 20,000 data points. So with the help of the result, you can use extrapolation factor for the species. So if you are using a study, you know the species, and based on that, you can calculate the extrapolation factor in your study. If you want to read more about the extrapolation factor and the comparison of our study with other study, you can go to our reference of our published paper and you can read more. So in conclusion, the final conclusion is we have a lot of chemical in our study, and most of the chemicals we are studying in 0 PM are persistent and mobile chemical, but we don't have a lot of characterization factor. So if we are calculating a product that include persistent and mobile chemical, for example, if we have a rain jacket and it is a PFAS coating, but if we don't have the characterization factor for that chemical, then we cannot calculate the total toxicity impact of the rain jacket with the help of LCA because of lack of characterization factor. And there is lack of characterization factor mainly because lack of ecotoxicity data available. So in our study, we first calculated new characterization factor for a number of persistent and mobile chemicals. But in another study, we also calculated a lot of effect factor for many studies. So if you know your chemical, then you can use our effect factor to calculate the characterization factors. Along with that, for harmonization, we also calculated a lot of extrapolation factor that are for different species. So you can calculate your characterization factor more accurately. But there is also a concern regarding we have a lot of unknown chemical and unknown mixture in the environment. To calculate the characterization factor for these, there is a research ongoing to use bioassays. So how to fill the data gap regarding the characterization factor for different chemical for which we don't have data, we can use bioassays. So if you want to read more, you can go to different references and read all about our results. Thank you.
Yeah, so we're going to switch kilter now a bit. And so I thought it would be good to give you kind of a very rapid one-slide introduction to the ideas behind environmental psychology. So in particular, the core idea is that actions or, kind of the decisions that we choose to take are not just rational trade-offs between risk and benefit. So we know from classic work by Tversky and Kahneman that humans are not just rational actors. We are affected by a range of internal and external factors, and this can also include social and psychological aspects. So any kind of behavioral science is an attempt to try and understand at the core why people take or don't take certain actions. And in this, we might be trying to promote positive actions, such as those which may benefit an individual's health or have some kind of net benefit for society more generally. And in environmental psychology specifically, we're focusing on people's interaction with the physical environment, which of course they both affect and are affected by. And this can include risks and benefits related to the use of chemicals, such as, of course, PFAS. Now, coming back to the idea of the essential use concept, as we've seen from both Roman and Rahul, that technical data is really important in ascertaining the specific functions that a specific substance, for example, is providing, whether we have good alternatives to that, be it, for example, through a chemical alternative or a procedural alternative, and also in ascertaining the different kinds of risks that may come with those substances across their whole life cycle and in different compartments. But when we are thinking about the European Commission definition of the essential use concept, we start with two quite broad categories. So we have necessary for health and safety, and critical for the functioning of society. And in particular, deciding what is essential to society in the first place is going to be quite a tough nut to crack, particularly if we don't try to fill that gap that we currently have and what people don't know about PFAS, what they consider essential in terms of what functions we actually need. As Roman has said, it's not just about the chemical function, but whether we need that function in the first place. So we need to go out there and sort of try to fill that gap in social data. As we've already seen from Corinna et al., there is quite a lot of variation, not a great degree of agreement, even just within the EU, on what sorts of PFAS use categories that the public consider essential. So what we can try to do as social scientists then is to go out and develop this evidence base, which basically involves collecting data on what different representative groups within society don't know, what they think about PFAS, where their main concerns are, as well as their ideas on essentiality, and the kind of factors that underlie the differences across these groups. Because one thing I'll say is that there isn't just one public, there are different groups within society that may both react to and think about PFAS in different ways. They might face, different effects of PFAS to a different extent, and it's important to take that into account. Once we kind of have this evidence base, the idea is to design and test best practice communications that are going to get that information about PFAS risks and benefits across to people in a way that is digestible. One way to think about this might be kind of the labeling of products that contain PFAS and how we do that. Once one has developed good lines of communication, the goal should always be to try and engage as many groups in society as possible in discussion and in decision making. The positives of this include, for example, looking for social consensus. So, as Roman mentioned, there may be cases where when people are informed about PFAS risks and benefits, they just sort of agree that we never needed that level of performance or function in the first place. Think back to the red soap. And basically, we can identify areas where we actually don't need alternatives to PFAS. We can also anticipate potential opposition. Obviously, not everybody is going to be happy about regulations that might restrict their access to certain products. And where the numbers are large enough that there would be opposition, we can sort of plan for this through interventions to overcome it. And lastly, of course, we can try to collect evidence on what kinds of alternatives to PFAS are acceptable to the majority of society and why. So it might be moderate increases in price, to what extent, reductions in performance, etc. And then we can try and feed that information back to policymakers and industry. On the other hand, a failure to kind of engage with people, including the public, a wider range of stakeholders, has so often led to suboptimal outcomes that the European Environmental Agency lists in its guidelines for risk regulators the need to ensure the use of lay and local knowledge, so non-expert knowledge, alongside the, of course, relevant expertise. And one of the reasons they want to do this, or they tell people to do this, is to avoid something called expert groupthink, wherein this naturally, of course, by the nature of expertise, it's a relatively small group of people, they come to some consensus and they think that everybody will act on this information in the same way or react to that information in the same way. And that's not generally the case. We have to take into account that different groups will interpret that information in different ways, and be wary of that when designing communications. So let's just jump into some very rudimentary data where we set out trying to look at what kind of differences arise across experts and non-experts when thinking about essentiality. And we have some basic everyday items that hypothetically could contain PFAS. We have makeup in there for linking it back to the idea of cosmetics. And basically, wherever the bar is below the blue line is where experts said it was less essential in some way than did the non-experts. And naturally, of course, we see makeup is falling as less essential to the experts. Why is this happening? Well, of course, as Roman said, there are different levels at which the essentiality can be thought of. And it's natural that these experts from within 0PM are thinking probably at the more strict level, do we even need PFAS in that product in the first place? Of course, no. But when we think about the European, not of course no, but it might be that they think no, if we have alternatives and it's from with 0PM. We then also need to look at what the European Commission report on the essential use concept says. And they basically reported that the majority of stakeholders found it inadequate to assess, for example, only this very strict technical level. You also need to take into account the product function and what that's serving. Particularly what we see is if we want to engage a wider public in these conversations of what's essential in the first place, we might need to kind of expand past just the technical sense of do we need that chemical or not. And indeed, when we interview non-experts as to why makeup comes up as something that's relatively essential for people, it is ideas such as high frequency of use. So something that I use daily must be essential to me. Some people report needing the feeling that they have to wear it for work. So an extreme example of that is kind of actors and actresses. And lastly, what's really interesting is it's brought up as being linked to well-being and mental health. So naturally, health is already a part of the EUC, but it's quite interesting to see it being brought up in relation to a product which we maybe wouldn't think of it as being linked to health. Now, we are seeing similar stances emerging from industry, particularly in position statements on the essential use concept related to the apparent need for derogations and authorizations related to chemicals being used in cosmetics. For example, we have a quote here from Cosmetics Europe that says 72% of consumers said that the cosmetic and personal care products that they use improve their quality of life. Therefore, any concept of essential use of chemicals should take a holistic approach, including the value to society. And while we agree it's useful to sort of engage the wider public in these discussions of essentiality in a way that kind of allows them to contribute not just the technical essentiality or the chemical essentiality, what we don't see in our data is that product essentiality equals PFAS essentiality. It often seems to be the opposite way around. So once you inform people about PFAS risks and benefits, actually products which are generally considered quite essential to their lives receive low ratings of PFAS acceptability. So here we have some exploratory analysis where we're basically looking at how the response, the items cluster together on the basis of response. And we have some everyday items that again can contain PFAS. And they're basically clustering together into a higher PFAS acceptability and a lower PFAS acceptability set of clusters. And we see things like, again, makeup, but also important stuff like dental hygiene products, period products, nappies, things which are generally of high essentiality are actually coming out as low acceptability for PFAS to be in them. So it's not that it goes hand in hand once people are actually informed about PFAS risks as well as the benefits. It's also interesting as psychologists to ask, well, how can the risk or the risk perception associated with these items differ so much? We could take the same substance, hypothetical substance, and it would be ascribed different levels of risk by people based on, for example, the context it's used in. Because again, these kind of psychological and social factors are acting on people's decision making. So one important thing that affects risk perception that we'll talk about more today is perceived body contact. So this is the proximity of the product or the chemical in the product when we use it, particularly if there's risk of ingestion or dermal uptake, which is of course very relevant for cosmetics and makeup, then this will inflate risk. There's aspects of fairness. So is everybody in society going to face the risks equally, or are some going to take the brunt of it? That's likely to lead to reactants. And there's also the vulnerability of groups. So in the previous slide with the products, we also had nappies and toys. And again, this is in the low PFAS acceptability group. And this is wherever a vulnerable group is exposed. This again inflates the risk perception. So as I said, we're going to dig a little bit more into the body contact effect with both qualitative and quantitative data. So this is a quantitative experiment where we basically gave people either household cleaner in a spray bottle or some kind of dental hygiene product. Here we show toothpaste, but we'd expect similar results with anything that you're kind of using in the oral sense. So let's say coated dental floss, for example. And we show those products first at a baseline, so there's no kind of chemical warning. And then we show the products again with different iterations of warnings relating to persistent mobile toxic substances that may be contained in the product. And naturally, we give people information, so lay definitions of persistence, mobility, and toxicity, as well as the wider context of PMT substances. And we asked them to rate these items on a range of risk perception measures, including concern about buying and using the product, support for regulation of chemicals in the products, and also emotional affect. So this is whether people are feeling positive or negative when imagining buying and using the product. And what we have on the graph is on the y-axis, as we go down, it's more negative affect, and as we go up, it's more positive affect associated with using the product. And what we have on the x-axis is just the extreme versions of the conditions. So the baseline with no warning versus the full PMT warning. And what's interesting to note is, despite this being, this most extreme category, we get this significant interaction wherein the slope, the blue line, is steeper for dental hygiene products. So the negative affect increases, more so people become have more negative emotions associated with the dental hygiene products containing these kind of chemical warnings. And indeed, of course, these people also, same people rate dental hygiene products as having more body contact during use compared to household cleaner. Now, you might say, why do we care about emotional affect? But actually, when people are performing risk perception as opposed to risk analysis, because they don't have the expertise, we know that the emotions that people are feeling are key drivers of what decisions they come to. And particularly in the consumer domain, we know that people try to repeat consumer behaviors that lead to positive feelings and try to avoid repeating consumer behaviors that have led to negative feelings. We can also see the effects of body contact in our qualitative data. So this is where we sat down and interviewed experts and non-experts about PFAS as well as essentiality. And what we did here is we had people basically draw out the pathways by which they think PFAS would go from being in a product, so here lipstick, for example, to being in the human body. And we do ask them to consider from production to disposal, so the full life cycle of the product. And what we see on the top is the kind of the general responses we got from non-experts. And from the bottom, of course, it's an expert model wherein we have a lot more interconnectedness and detail. What's really striking from the non-expert dialogues is that there is a fixation again upon the use phase. So again, it's about direct exposure to the product leading to, PFAS being in your body. So they say things like dermal uptake, accidental ingestion, particularly if the product's used on the lips. They do bring up the fact that, of course, when I take it off, if I wash it off, it goes down the drain and it enters the waterways. But they don't as often or as strongly make that link between PFAS going into the waterway, for example, and then it ending up in drinking water or in food, for example. And what's really lacking is insights into why there would be PFAS pollution from the production phase. So, of course, people's concerns are valid about direct exposure. There is a risk of dermal uptake, there is a risk of ingestion. But what's concerned is it suggests that uninformed people may think they can protect themselves simply by not using consumer products containing PFAS, which is, of course, not the case. It also means that they're less likely to understand and support restrictions on the production and disposal phases. So what this kind of exercise teaches us is that at experts we have a kind of role now to try and increase awareness about why, if we really want to reduce PFAS pollution, it has to be reduced at its source, so production and use of PFAS, and that's something that needs to be gotten across to the public through better communication. Now, very lastly, I want to show you some very hot off the press data that we're currently wrapping up this week. So this is around 800 to 1,000 people per country across 3 countries in Europe. And we wanted to look at what kind of policies regarding PFAS that people support. First off the bat, 2/3 of people reported never having heard of PFAS, which might be quite surprising to people who deal with PFAS daily, because it seems like we constantly see stories about it in the news. But despite this, the majority of people still report never having heard of it. However, once we give them information about PFAS, they do support a range of what we call both push and pull measures, or carrot and stick measures, in tackling PFAS pollution. So if we just look quickly at the big graph on the left, what this is how quickly should PFAS be banned or rather restricted. This will also depend on the type of PFAS we're talking about and the use context, how easy that will be. But what's nice to see is the majority of people, at least in this sample, want PFAS dealing with sooner rather than later. And what I think is particularly nice is the majority are responding, they want something substantial doing by the end of 2030, which is, of course, a bit more realistic than by the end of 2025. And if we move over to the right, what we see is the kind of policies they were most supportive of. People really want PFAS to be labelled, PFAS products or products containing PFAS to be labelled as such. So this is quite nice, going hand in hand with the CLP classification of, for example, PMT, PBT substances. They're also in support, high support of stricter regulations and higher fines for those who do pollute with PFAS. But it's not all bad news for industry, because they're also very in support of the development of incentives for new technologies and new materials to replace PFAS. So it seems that EU policymakers actually have a range of what we say these push-pull measures in tackling PFAS pollution, wherein it seems like there are quite a few different approaches and people will support them. What we'll be doing next is extending this to other countries. So if you have something interesting you think we could do, please let us know. And we'll also be looking into the kinds of factors about the individuals that predict whether they're the people saying, I support regulations or I support incentives. They could be the same people responding yes to both, but we need to look into that and understand what kinds of people respond yes to this versus that. So that's all I'm going to talk about today. And I hope you've enjoyed this part of the webinar and the webinar more generally.
Okay, thanks so much, Ellise Suffill and Romain. So this was a very nice interdisciplinary exploration of the essential use concept, featuring some of our latest 0 PM results. And there's a very active Q&A going on. That's also great to see. And some of the questions have already been answered live. So in the time we have left, in the remaining 13 minutes, I will try to get to these. And I will favor first questions that aren't anonymous and for which somebody flagged to answer. So that brings the first question from Petra Ekblom to Romain. I'll read it to you, Romain. I have a clarification question regarding Allura Red. I would assume that you conclude that the use of the PMT substance in the lipstick is a non-essential use for society based on the technical function only, in part decorative properties, bracket. Thus, even if the substance is needed for the product for it to be red, this is not a necessary use for society that would justify the use of this PMT substance, end of bracket. This would not be considered necessary for health and society or critical of the functioning of society according to the Commission's communication. Could you please clarify your thinking on this?
Yeah, so at the time of the study we did on cosmetic products, the communication from the Commission was not published yet. So we didn't have any criteria on how to evaluate what is necessary for health and safety. And we didn't want to answer that question ourselves because we figured that was more of a social scientist job. It was not for us to answer that. And also, just by looking at whether or not the technical function of the substance was it needed in the product, and by answering whether or not alternatives are available, we could already conclude that the uses of Allura Red were not essential in cosmetic products because they are safer alternatives, potential safer alternatives. So we didn't answer that question. But since then, so like Petra is saying, the Commission published some criteria for what they would consider as necessary for health and safety. And I agree that according to those criteria, uses of Allura Red in lipstick or makeup does not satisfy any of those criteria. So they would not be considered as necessary for health and safety anyway. A discussion can happen on whether or not those criteria are like good enough, but I think that's the topic of this webinar. But yeah, it's just to bring clarification to that.
Thanks, Romain. And I'm seeing the next non-anonymous question from Hiram Merman. I guess it's to you, Ellise. To what extent is essentiality, to what extent is essentiality a conclusion only relevant at a certain point in time? In other terms, is essentiality an absolute attribute of a use of a context-based assessment and as such related to a political context and should be a political decision? Can social scientists provide an analysis of this aspect? So the context of when this.
Yeah, I mean, this is something that's even mentioned in the kind of Cousins et al. Paper, first trying to sort of apply the essential use concept to PFAS or the case of persistent substances, is the need to keep looking back through the social context, right? So one thing a few years ago that was super important, that was a use of PFAS, was potentially in FFP2 masks. So of course, very relevant back then. When we first started doing the interviews, it's something that would come up more often as essential. And over time, that slowly drifted away. So just as you need to sort of, once an authorization period runs out, you reassess whether there are new alternatives that can mean we can get rid of a certain chemical that we couldn't get rid of before or replace. You should do the same thing in terms of essentiality and check where we are in terms of, do we still need to keep that use or not? Or do we actually need to bring in a use that we didn't consider essential before? For example, in response to health crises. Yes, it's going to change over time. Depends on the context.
I'd just say that's a very interesting response, and I see this also come a lot with use of PFAS as a fire foam retardant in an emergency. It's a question of, do we trade the acute risk, managing an acute risk of putting out a fire, for having to deal with a chronic risk afterwards? So very interesting. I think this is also to you, Ellise. Does it actually matter? This is from Thijs de Kort. Does it actually matter who brings the message about the full life cycle risks of PFAS to the general public? Where should this message be coming from?
I mean, I'm not going to say who exactly it should be coming from. It's just that, of course, you have experts in a specific domain, and you might have experts in risk communication who might help in translating that information in a way that's going to make it, let's say, digestible to a range of people. Another really great method is something which tends to happen more at a governmental level, be this within specific communities or even wider, is something called citizen panels, where they basically bring in representative members of society, not just a small number of them, and they have them basically do crash courses on issues with the experts so that they can better engage in discussion with the experts and get a feeling of, the actual nitty-gritty going on behind the scenes. It allows them also to make better trade-off of do we need PFAS or not? If I tell you just the risks of PFAS, you're going to say, oh my God, no, we don't need it. But if we talk about the benefits in a more nuanced way, then the answer is going to be somewhere in the middle. It depends on the context. So I think, again, it's about not just who tells the public, but it's how we interact with the public. It's bringing the public into the discussion rather than just sort of one directionally launching information at them, if that makes sense.
Thanks. Next question from Michael Gary. I'll just pitch this for a reply from Romain and Rahul. Does essential use include degradation products, like TFA is a degradation product of fluorinated gases? So maybe just comment on that and comment on how you consider degradation products in your work.
So from my perspective, I think degradation products are not part of the essentiality assessment per se. It's more to determine whether or not the substance is a most harmful chemical or not. In the case of fluorinated gases, maybe the fluorinated gas itself is not that persistent, but if it degrades to TFA, then you can consider it as a PBT, PMT, and it should be considered as the most harmful chemical. But in the essentiality assessment, I don't think it's relevant in the essentiality assessment itself, I mean.
From the life cycle point of view, if you are using a chemical and it is not toxic, but if it has a degradation products that is very toxic, so it is important to include that, because otherwise you are underestimating the total toxicity of the product. So from the LCA point of view, if you are calculating the overall toxicity, then you have to include everything that is a part of life cycle. That includes the life cycle of the chemical, when it is used and when it is emitted until it is degraded to the final inorganic chemical. So everything is a part of it, including degradation product, but the limitation is how to include it, and it is very complex to include within LCA.
Great. Oh, thanks both. And so now I see many more questions have been answered in the Q&A chat. So I'll go to the next unanswered question. First one from an anonymous attendee. I think this one goes to Romain. Does the assessment of essential use consider different use conditions where the PFAS is used, for example, because some of the alternatives might not withstand those conditions, maybe high temperature conditions, I guess. Otherwise, it is easy to conclude on an alternative, but their applicability and exact applications is a different story.
Yeah, so when we build the alternative database, we couldn't go into the details of every specific conditions for every applications. There are too many of them. So we just gave an overview of what potential alternatives have been identified so far, but a proper alternative assessment is still needed to make sure that the alternative we have listed there satisfy the specific conditions of a process or product. So it's just to give the first step when we try to identify a potential alternative to PFAS.
Mm-hmm. And great, no thanks. And then a clarification question, I think, about the alternative assessment database. So it says in the alternative database, the alternatives for pesticides only link the indication, example herbicide for herbicide, but this is a limited value as a substance cannot be used interchangeably due to different modes of action for, in this case, the plant or animal or bug. Are there any plans to provide updated and corrected information for these types of substitutions, engaging with the experts in crop protection industry, for example?
Not immediately, no, not in the near future. I completely agree that that's a bit too easy, maybe. But again, it's just to give a first idea, and I'm sorry if it's not that helpful. I'm not a pesticide expert myself, so it was just my first idea. But no, it's not planned for the near future, at least.
Yeah. And also add on to that, it's like we see the alternative assessment database as a start, so it might not go into technical details about the exact function, just the category of function, and there's different categories of function, but also like the assessment of alternatives might not also be complete. It's just this is what we have at hand, so it's just to help people give a start on their journey to alternatives assessment. It is not the end right now. Okay, good. I'm seeing Ellise is answering a question about cosmetics. I'll go to this question. Well, Ellise, okay, there was a clarification question. Was the psychological perception mainly focused on consumer or professional uses only?
Yeah, so I think particularly in broaching people in this discussion about PFAS, we've focused on the consumer part, but what we see from that is the issue that we have this, as I said, this kind of pull towards direct exposure, particularly in relation to body contact. And what that means is we're already seeing, even for consumer products, a lack of knowledge regarding emissions during production. And indeed, of course, a lot of emissions relating to PFAS are from industrial uses. So again, kind of probably what's going to be another kind of key need in improving awareness is that once people know something about PFAS, the fact that there are risks, there are benefits that we don't know exactly how much normal people are exposed to. We know the links are there for people who are highly exposed through, for example, living in proximity to factories or working in factories producing and using PFAS. We have to get across that there is this uncertainty, that it's not just one way PFAS is bad. But once people have the information about PFAS, then we need to increase awareness that, yes, these emissions are coming from particular sources. And, people, when given information in a certain way, can understand, something has a huge tonnage versus something has a tiny tonnage. And once you make people aware that their exposure is not just through using or not using consumer products, then they will also have a better idea of where, the key amounts of PFAS entering the waterways, for example, are coming from. So I think, again, it's an education thing. Or increasing awareness, better communication, I should say.
Oh, great. And thanks so much. And I see we're almost out of time, and there's some more interesting discussions in the Q&A. Maybe I'll just try to get a wrap up from both of you, just to answer to this kind of synthesis question. Is it important to use the essential use concept to facilitate and make easier the transition to safer chemicals, implying that will this be a tool that can be used to help industry transition quicker, and will it support, for instance, innovation incentives? What is your take on that? I'll start with you, Romain.
I struggle to know whether it's going to make things easier, going to make things different, for sure. I think it's a great tool to properly justify whether or not a really hazardous chemical should still be allowed on the market. And it's a great tool to encourage innovation, to find alternatives for those essential uses, for sure. But whether or not it's going to make things easier for regulators, I think it's too soon to say. We need definitely better guidance and more detailed guidance to evaluate that. Right now, it's still too early in my perspective to say that.
Thanks, Romain. And yeah, just to, since we're over time, just a few words, Rahul, and a few words, Ellise. Rahul, next.
From my point of view, it depends on who can decide. It is mainly the decision making. It is not black and white, whether it is essential or not. It is for whom and who has the power to decide and how flexible they want to be. So it is regarding the decision making on that.
Great, thanks. Good point. Ellise.
I think Romain and Rahul have said it really well. I cannot say whether it will make it easier at a technical level or on a regulatory level. It's very interesting from a psychological level in that we can potentially find areas of social consensus where people agree. But naturally, again, you're going to have areas where people disagree, and then what do you do in that scenario? So again, it's a non-answer, but
Great. No, thanks. But more work forward. And thanks for this great insight, everyone. And thank you, everyone, for tuning in to this webinar on the essential use concept. And you will find the slides and on Zenodo and the video recording on our YouTube channel. And go to 0pm.eu and subscribe to us on LinkedIn to see future webinars on the zero pollution of persistent mobile substances. So on behalf of all our three speakers, Ellise, Romain, and Rahul, on behalf of Sarah Hale and myself, Hans-Peter Arp, thank you very much for tuning in, and we'll see you next time.
0 PM. Zero pollution of persistent and mobile substances. This project has received funding from the European Union's Horizon 2020 Research and Innovation Programme under grant agreement number 101036756.